All right, so we're starting Unit 4, Lesson 1 today. So if you haven't yet, pick up the packet and the purple sheet from the front table and start the bell work. So only allow about 5 minutes for the bell work. You are going to review gateway number 2, basically. So you need to identify the values of theta that make each equation true over the interval from 0 to 2 pi. Notice the bracket before the 0 and the parentheses after 2 pi. That means 0 is included, but 2 pi is not. So if I have sine equals square root of 2 over 2 is the same thing as saying 1 over square root of 2. Depends on which way you prefer seeing it. They're the same. Sine is positive in quadrant 1 and 2. Square root of 2 over 2 means that my angle is a 45-degree angle, so that is pi over 4 and 3 pi over 4. Okay, those were those two. Okay, for B, cosine is negative, and it's negative in quadrants 2 and 4. Figure out what these are by figuring out your reference angle and go from there. So that's what you're doing. So I did A for you. You need to do B, C, D, E, F, G, H. So pause the video, take 5 minutes or so to do that, and then resume the video. All right, so how can we tell the difference between when we should solve an equation, which means we can move things from one side to the other of the equal sign, or when we should verify an identity, which means you work only with one side until it looks like the other? Well, you can do two things. You can look at the directions for the problem, or look at the graphs of each side of the equation and see what happens. If they're the same, you know you're verifying. If they're not the same, you are solving where they intersect, okay? So if I look at the problem for number 1, or here, it does say solve, okay? So I'm going to solve the equation. I first need to get cosine theta by itself. So cosine theta will equal 1/2. I had to divide both sides by 2 to get the cosine theta by itself. Okay, cosine is positive in quadrants 1 and 4. If it's 1/2, it means I have a 60-degree angle, so I have pi over 3, and let's see, 5 pi over 3. All right, now if I wasn't sure on that, I could graph 2 cosine theta. So that means my amplitude is 2, so cosine would start here. Its period is 2 pi, so halfway through it has to hit the bottom of the amplitude. There we go. And I really only need to graph from 0 to 2 pi because that's what our interval is looking at here. So that's that side of the equation. The other side of the equation is 1, so y equals 1 is right here. And that reveals our two solutions. Okay, it's when x would be pi over 3 and 5 pi over 3 if I drew that right. Okay? All right, so establish or verify. So those directions are telling me I'm going to prove that this side equals this side so I don't cross the equal sign. All right, if you can't see that right off the bat, we could graph it. So let's graph the left side. That is not a graph. We have not graphed anything that looks like that. So use your calculator or Desmos to graph it, and you will get a graph that looks like this. Okay. Then if I go to graph the other side, that tells me my vertical shift is 1. Cosine has the amplitude of 1, so it also would look like this. Whoops, pretend I made it there correctly. So it's on top of each other. So that's how we know we need to get the left side to be equal to the right side. Now, 1 minus cosine x is not part of one of the identities that we know. But sine squared x has part of an identity, or is part of an identity that has something that looks very similar to it. So let's replace sine x, or sine squared x, with 1 minus cosine squared x. And that is over 1 minus cosine x. And right here, you cannot just start canceling things out. This is one term here. But I could do the difference of squares, and I end up with 1 minus cosine x times 1 plus cosine x. And that is still all over 1 minus cosine x. So these now can cancel because that's whole terms canceled out. And I'm left with that, which is what I was trying to verify. All right, so now what we're going to do is solve. So we need to do a couple of things. We are basically going to use the main strategy of just using algebra skills to isolate the trig function. Then we use the strategies from gateway number 2 to find all those angles between 0 and 2 pi. Okay, so it has 2 instructions here. For A, we're finding the interval between 0 and 2 pi, including 0. And then B, we're giving all possible solutions. And I'll show you how to do that in a second. So first, we have to get cosine theta by itself. So I'm going to divide both sides by square root of 2. And I get cosine theta equals 1 over square root of 2. So going back to gateway 2, cosine is positive in first and fourth quadrants. Okay, I need to know my reference angle. If the cosine is 1 over square root of 2, I know that reference angle is 45 degrees. So that is pi over 4 and 5 pi over 4. All right, now for B, it wants all possible solutions. So that means if I do 1 whole revolution or 2 or 3 or go backwards this way and do a whole revolution, whichever, okay, it wants all the solutions that is possible. So I'm going to take this pi over 4. I know my period is 2 pi. So if I add that to it, but I could add 2 pi to it multiple times or a negative amount of times because I could go counterclockwise instead. So we're going to multiply it by a variable k. That will include every possible pi over 4 angle that could be included, okay? Then we have this 5 pi over 4. Well, say I go around my circle more than one time. So I need the period of 2 pi, but I don't know how many times they're going to go around, so I'm going to add k to it. So that is all the possible solutions and on the interval from 0 to 2 pi. So let's do the same thing with number 2. So I need to subtract 5 because the goal is always to get the sine x by itself. So we have to work our way there using the algebra that we know. So 4 sine squared x now equals 3. I'm going to divide by 4. Sine squared x equals 3/4. I need to get rid of the squared. So I'm going to square root this side and it cancels it out. But when I square root this side, I get a plus and minus. So we end up with sine x equals plus and minus the square root of 3 over, and I can take the square root of 4 and get 2. Okay. Well, this includes all values where sine is positive and negative, which, guess what, puts us in every single quadrant. Okay. So for A, well, we got to figure out the angle. If sine is square root of 3 over 2, I know that angle is 60 degrees, so it's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, that puts me in every single quadrant with a reference angle of 60 degrees. So for B, if I take pi over 3, it's right here. This one is technically 180 degrees or pi radians over. And then if I went pi again, I'd be back there. So if I just add pi, even though my period is 2 pi, if I add pi, I get to the quadrant 3. Then add pi again, I'm back to quadrant 1. So if I just multiply pi times k, that takes care of all of them. And then, sorry, I'm going to change colors here. If I do the quadrant 2 and add pi, I get the one in quadrant 4. And I can add pi again and again and again and again. So that gives me 2 pi over 3 plus pi k. Now, I will accept those answers because, you know, it's a lot less writing. But if you took all of these to get B and you put pi over 3 plus 2 pi k, because that's the period, and 2 pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k. You're not wrong. I will take that too. It's just that's a lot more writing when you can just add pi and it puts you in all those other quadrants. Okay, oops. All right, let's do the last two here. So square root of 3 cotangent x plus 1. So let's solve for cotangent x. Needs to be by itself, so I'm going to subtract 1. Square root of 3 cotangent x equals a -1. Divide by square root of 3. Now we have cotangent x equals -1 over square root of 3. Now when we're dealing with our unit circle, we like to have our 3 main trig functions. So I'm going to change this to tangent, which is now negative square root of 3. So tangent is negative in, my brain just stopped, sorry, in quadrant 2 and 4. Okay, so we need to figure out our reference angle. Well, if it's square root of 3, then I knew this was square root of 3 over 2, and this is 1/2, -1/2. So I know it's 60 degrees. So for A, I know I have 2 pi over 3. And then the one in the fourth quadrant would be 5 pi over 3. All right. Now, let's start with this one. For B, I'm going to have the 2 pi over 3 plus, well, our period for cotangent and tangent is just pi because it'll get me right there. Pi times k. Whoops. Oops. I'm just making lines everywhere here. Okay. Now, we always know, and the reason that works and we don't have to add the 2 pi or anything is because we know that tangent and cotangent are positive in quadrants 1 and 3. So if I just add pi, it puts me in the other quadrant. Okay. And they're negative in quadrant 2 and 4. And again, adding pi just gets you to the other quadrant. All right, let's try number 4. All right, I'm going to do 2 things off the bat here. I'm going to move my cosecants to one side. And I'm going to subtract 2 to both sides. So these cancel and leaves me with 2 cosecant theta equals 2, and then these canceled. Okay? Let's get cosecant theta by itself, divide by 2. So cosecant theta equals 1, which means sine theta equals 1. And sine being 1 is right there at pi over 2. So A is just at pi over 2. Because 3 pi over 2, it's -1. So we just want the positive, which means B will be pi over 2. My period is 2 pi times k. Because you have to go all the way around to get back to it. All right, so to solve these trig equations, you first solve for the trig function. Then you find, all of the angles that satisfy the simplified equation, and finally find the values that satisfy the equation are called the solutions to the equation. All right, so your job now is to go to page 3 and complete those 8 practice problems.